Welcome to GATE preparation. Today we will solve question number 41 from GATE 2022. The question is given as the measure products M and N in the given reaction sequence are, as you can see, this 4-ethyl cyclohexanone is treated with a sequence of reagents to produce M, which on treatment with an excess amount of divalage gives N. So we have to determine the structure of M as well as the structure of N. Before moving to the solution part, let's have a look at the basic concept behind this question. The question involves a name reaction called Favorsky rearrangement. This is basically the rearrangement of alpha haloketones to the corresponding carboxylic acid or esters in presence of base such as sodium hydroxide or sodium alkoxide. Now, the rearrangement can take place in acyclic as well as in case of cyclic system. For example, this 1-chloropropanone in presence of sodium hydroxide can undergo this rearrangement to give the corresponding propionic acid. Similarly, this 2-chlorocyclohexanone in presence of sodium hydroxide base can undergo the rearrangement and give the corresponding ring contracted carboxylic acid product. Now if we look at the mechanism, the hydroxide can first abstract a proton and generate a carbon ion over here. Now this carbon ion can attack on the halogen containing carbon to give the corresponding fused cyclopropanone intermediate. Now in presence of hydroxide, it can further undergo a nucleophilic addition followed by ring opening. So the ring opening can take place either this side or this side, but as it's in a symmetrical system, we will get only one ring contracted product. But depending on the substituent present on this adjacent carbon to this carbonyl center, the reaction can take place through a different pathway and we can get a different product. For example, we look at this compound. As usual, at first base can abstract this proton and can generate a carbon ion here. Now this carbon ion can attack on this quaternary carbon center and upon chloride elimination we will get this fused cyclopropanone intermediate. Now in presence of methoxide, it can further undergo nucleophilic addition and then ring opening. But if we look at this system, this is not symmetrical anymore. So depending on which side the ring opening is taking place, we can get to different carbon ionic intermediate. For example, if the ring opening is taking place on this side, we will get this carbon ion. If ring opening is taking place on this side, we will get this carbon ionic intermediate. Now we have to see which intermediate will be more stable. So the reaction will proceed through that intermediate. Now this anion could be stabilized by only the minus I effect of this chlorine. But this anion could be stabilized through a resonance with this ester functional group. So definitely this carbon ionic intermediate will be more stable than this carbon ionic intermediate. So the reaction will proceed preferably through this intermediate. Now this carbon ionic intermediate can further undergo an elimination to give this cyclopentene product. Next, the question involves a reducing reagent called divalage. Divalage is diisobutyl aluminium hydride, which is a bulky reducing reagent. Most of the time, this reagent is used to convert an ester or nitrile group to the corresponding aldehyde group. This reagent can also efficiently reduce alpha beta unsaturated ester to the corresponding allylic alcohol. This divalage exists as a dimer in solution. this is the dimeric structure of divalate. With these basic informations, let's move to the solution part. So, as we saw in the question, this 4-ethyl cyclohexanone is treated with sodium hydride and then this dimethyl carbonate reagent. So, in presence of sodium hydride, can abstract a proton from this position as well as from this position. But as it's a symmetrical molecule, so either side will give the same carbon ion. For example, in the carbon ion is generated over here. Now, this dimethyl carbonate could be written as now this carbon ion can attack on this electrophilic carbon center and upon methoxide elimination, it will give the corresponding beta keto carboxylic ester product. Now, on treatment with two equivalents of bromine, bromination can take place on both sides of this carbonyl group. Now, this compound, upon further treatment with sodium methoxide base, can undergo a Favorsky rearrangement as we discussed before. So, at first, the methoxide can abstract a proton and generate a carbon ion here, and it will attack on this quaternary center, and we will get this fused cyclopropanone system. And upon further nucleophilic addition followed by ring opening, we will get the corresponding carbon ionic product, and definitely this is the more stable intermediate compared to this one as we discussed earlier. Now this intermediate can undergo elimination and give this cyclopentene derivative. So this is the structure of M. Now M is treated with an excess amount of divalate. So as we mentioned, divalate can reduce alpha beta unsaturated ester to the corresponding allylic alcohol. Now if we look at this system, this is an alpha beta unsaturated ester moiety, and also this is an alpha beta unsaturated ester moiety. So both the ester group would be converted to the corresponding alcohol functional group. So this is the structure of N. Now let's move to the question slide and see the options. So as we saw, M is a cyclopentene derivative in which the both ester groups are present on both the alkene carbon atom. So this is the correct structure of M, and as you see, no other option contains this structure, so you can just eliminate all those options, and definitely this is the correct structure of N. So option B is the right option. Now, to know about Favorsky rearrangement in details, please visit this link and go through this lecture. Thank you.